Hello everyone, I am Dr. U. Sakthi from SRM Institute of Science and Technology, Katamrattur, Chennai. Today we will see about ensemble learning and learning for decision making in AI. First, I will see what is ensemble learning. It is the most powerful machine learning techniques for solving regression and classification problem. Here, it combines multiple weak machine learning models into one predictive model to improve the accuracy and reliability of the prediction and the classification. Here we have multiple weak base learners. The output of base learners are combined to get the solution for our ensemble learning model. Here, the ensemble method combines the insights obtained from different machine learning models to improve the accuracy and the machine learning process. Here, why we are going for ensemble learning? Here, it combines the insights of that is positive strength of different burst learners models to get the more accurate result. Here in this process, the error rate is reduced. For example, the bias value and the variance can be reduced by using different models, and the accuracy can be increased. And ensemble model and error sources. Here we have three different models: model 1, model 2, model 3. Output of these three models are combined. That is called ensemble model. Then the output of ensemble model has more prediction accuracy than the individual weak models. Here the bias and variance are the major sources of error. The ensemble method minimizes these errors. It gives higher predictive performance. First, we'll see what is bias. If the machine learning model is not accurate, it can make predictions error. And these errors are usually known as bias and variance. Here, the bias is the difference between the prediction values and the actual value or expected values of the model. That is called as bias. And variance is the amount of variation in the prediction if the different training data sets are used. That is called variance. Here, by using this ensemble method, the error value of bias and variance can be reduced so that the accuracy will be increased. Here, this ensemble method, it provides better performance than a single model. It has three components: data sets. Different samples are generated from given data sets, and the base learners, the different base learner models, and the final model output. Here, the training data set is divided into multiple samples: training data 1, training data 2, and training data n. The different training data sets are given as input to the learning model. So we have n type of base learners, that is called different learning algorithms, learning approach 1 to up to n. Here, all these models produce the output. Prediction, or it may be classification. That outputs are combined as a single output, that is called combined predictions. So here, if we combine all these models, error rate can be reduced and the prediction can be increased. Then the types of ensemble method. There are two types: sequential ensemble methods and parallel ensemble methods. Sequential ensemble methods means burst learners are generated consecutively. There is a dependency between the burst learners. One burst learner output is given as input to the next burst learner, base learners. The performance of the overall model can be boosted. So the learners are more, executed in series model, in sequential model, one after another. But in the case of parallel ensemble method, base learners are executed in parallel. There is no dependency between the base learners in parallel ensemble method. And there are different methods of ensembling process. The first one is called averaging. The average is calculated as sum of all models output divided by total number of models. Each model makes equal contribution to the final ensemble model. For example, we have three models. Three model output is called as P1, P2, P3. P1 is prediction of model 1, P2 is prediction of model 2, P3 is prediction of model 3, where P is a prediction of ensemble method. So P is calculated as P1 plus P2 plus P3 divided by 3. So we have three models. That is, the prediction is sum of prediction of three models divided by number of models. So example, decision tree, SVM, and linear regression. Here all models makes equal contribution to the output. This is called averaging. And when we go for weighted averaging, it is extension of averaging model. Here, the best learners are outputs are contributed based on the performance of the model. For example, decision tree 50%, SVM 30%, logical regression 20%. So the contribution of each model is based on the performance. So here we have three models. So each model has weight and the prediction value. So W1 plus W2 plus W3 equal to 1. So weight of each model. And P is the prediction of ensemble model is calculated as P1 into W1 plus P2 into W2 plus P3 into W3. So here in the previous case, the averaging all models makes equal contribution. Here, based on the performance, the contribution value is divided based on the weight. And bagging. So bagging, it combines the result of different models to get the general model result. There are three steps. First step, bootstrapping. Second one, execute several base learners or samples. Step 3 is calculate average of all predictions to find the ensemble predictions. So backing or bootstrap aggregation reduces the variance by calculating the mean of multiple estimates. It minimizes the variance and overfitting. What is bootstrapping? It creates randomly sample data sets of the original training data sets is called bootstrapping. And after generating the different samples, the machine learning model is this base learners are executed on the sample. And the third step is calculate the average of all predictions to find the ensemble predictions. So there are three steps. That is called bagging. Next one is called boosting. The first method is trained on data sets. Then the second model is trained to correct the error present in the previous model. So it is an iterative algorithm that adjusts the weight based on the previous model. AdaBoost is the first boosting algorithm. Here it combines multiple weak classifier to form strong classifiers. It reduces biases and increase the ensemble prediction accuracy. And the burst learners are trained in series, one after another. So first model is trained and we have the output, and the second model is trained based on the error available in the previous model. That is called AdaBoost boosting techniques. It combines multiple weak classifiers into one strong classifier. And the random forest classifier is good example for ensemble learning models. Random forest combines various decision tree models. It combines the advantages of different decision tree models to get the ensemble models. It creates a random subset of features. So random forest classifier is the best example for ensemble learning models. And the ensemble learning model is one where multiple learners or multiple learning algorithms are trained. In most of the learning algorithms, single hypothesis drives the learning. In ensemble learning model, the whole collection or ensemble of hypothesis is selected from the hypothesis space and the predictions are combined. In this approach, the learners are referred as base learners. So we have multiple base learners to get the result for ensemble models. The most commonly used ensemble learning methods are boosting and backing. Boosting can be broadly defined as the method for generating accurate predictions by combining the rules that are comparatively inaccurate. And boosting incorporates the weight of multiple data sets. The weights of training example reflect the importance of training data sets. This is called bootstrap sampling, where training data with the replacement is taken in the learning approaches. And the next topic is learning for decision making. Nowadays, in business, AI tools and AI techniques helps to make better decisions by analyzing the data sets. AI eliminates the bias in decision making. So the error is reduced and the accuracy rate is increased. Here, AI supports to make fast, accurate, and consistent decisions. And there are three types of learning for decision making: unsupervised learning, supervised learning, and reinforcement learning. And AI plays a major role in business models that will AI is used for predicting the demand, or it is used for finding uh, the cost, the profit, and the business strategies for increasing the profit and reducing the cost. So AI plays important role in decision making process. Thank you, everyone.